Now we're going to go over some things a programmer might need to know. So here's a file. If I hit F5, does this. Let's convert it so that it can, instead of running just in time, let's convert it so that it can be compiled into a binary. So we say include, then F4, then go to OS main and go to static atom, and then change that to colon. Okay, so what this does is it imports all the symbols in Atom. So save that. Then let's static compile. Uh-oh. Okay, well, let's just get rid of that. Static compile. Unused variable. Okay, that's just a warning. So now we have a binary file. We can load it, and it automatically runs because we had because this had that call down at the bottom, so it automatically ran. Now if we do bin rep test.bin.z, this tells the module it's aligned to one. It's got no alignment. It's got 7 absolute addresses that needed patching. It exports draw it song task in rows. Main is a this is, you can have multiple main routines, and it imports the following symbols. So you can have deferred imports. It doesn't have to exist at the time. Anyway, so that's that. Let's go look at some assembly in the demo assembly directory. BuzzFizz. You want to use enter and leave for your functions because the base pointer is used by the wallpaper and stuff, or I don't know. Yeah, for the wallpaper, it's used to figure out to trace the stack. There's a function called caller, which will return whoever called a task, and it can go up the stack. So use the enter and leave, and so you can either import or you can use these ampersands, and so this is BuzzFizz. Instead of defined byte, you use DU8 because it's an unsigned 8-bit, and you have to put a semicolon on the end of these. And I put these defines outside just out of habit. They can go inside too. So this is BuzzFizz. Anyway, that's an assembly. I'd hit F5. You can only include these once. Most code you can, if it's C, you can include it multiple times and it just overshadows. But with assembly, you get errors because it does forward references. Assembly can jump ahead, and so therefore redefining screws it up. Now we're going to go look at, we're going to do some profiling. This is how you figure out how to optimize. So we go to Game Starters and Eagle Dive. This is the flight simulator. First of all, we say dock max. That sets the command line buffer to unlimited. That's so that it won't run off this. You want the buffer not to overflow. Then we say prof all, and that'll profile all. You can do multiple levels deep. Then we say prof. We don't have to put these all on one line. These are all main, and then we say prof rep. Now if we want this to go to well, anyway, so F5. So right now we're 1,000 times a second we're recording where it is. So I hit Shift Escape, and then we get a profile report. This is the update the screen. That's where it's right into VGA memory. Converting. H line is where it's drawing the triangle, drawing the triangles. Let's see what else we have. Well, that's interesting. I don't know why that's our time is using a lot. Now it can't it has to wait for it does a lot of waiting on other cores, so it's got a certain amount of idling that takes place. Anyway, now let's go look at document forms. Okay, so when you declare a class, you can declare metadata, format string. These can be any name. Format string is one that's recognized. And then these are $ data. You want to use Control L to do these. Control L will help you with $sign commands. Anyway, or insert widget. So you say insert widget, and this is a data entry, a data. Anyway, so you want to do those. Then when this runs, it calls document form do. That's do form. We don't have to. Well, anyway, so and then then we called class rep, like we talked about earlier, to show. Anyway, so now TempleOS has a if we go Control D and then do OS main, in the main, the compiler has internal types. This is a U16 internal. A U16 is a when the structure's taken together, it's a U16 internal. Let me explain this. An I64 is a union of 8 bytes unsigned, 8 bytes signed, 4 words, or 2 D words. Anyway, so it's a union. and but it's also one value. So when we set a Q equal to that, then we can access the sub words and sub bytes. Anyway, and you can even do sub. Anyway, so this it's actually not very efficient because it forces it out. It won't use register variables if you do that. Anyway, let's look at the help for debugging. I just want to go over some things. So document dump is dynamic, so you can edit and change. If you just do dump, let's say let's dump the. Oh no, better not. This is the task record. If you say document dump, then it's dynamic and we can edit it. Anyway, mostly I do printf debugging because it's well, you'll find out. Now you can do raw output to the DBG. This is raw output. If you have a task that doesn't have a window, you can do raw output. You can turn on. You can do ctrace to trace the output of the compiler. If you're curious about the assembly, there's unassemble function. There's unassemble, and then you give the function an offset, or unassemble function, and it'll tell you the registers as well. Anyway, so there's you can get a stack report. Anyway, so go into the help and look at debugging. Now I want to go over a couple things. In my disk code, when it's waiting for activity, it's waiting for a port to change from busy, and then it does a yield. What this is, it takes half a microsecond to swap tasks. So it actually takes longer to read the port than it does to swap a task. Now this is not for servers, it's for home computers with people doing recreational programming. So you might have I don't know, 10 tasks, how many? Anyway, so it goes through the tasks and gets back to this task. It goes in the circle and then gets back to this task. So that's how I do I/O. Now, if you're curious why you can't, if you're curious why you can't access, you can't do some things when it's busy. If there's a big disk request, it doesn't break it into pieces. That's just the way this works. It's simpler. It doesn't do sharing. It doesn't do locks. So don't do anything stupid. That's just the way this works. Anyway, I want to go over one more thing. Let's go over exceptions. Exceptions are done with a throw, and it's a variadatic or whatever. I can't say that word. And when you catch, you have a off the FS segment register, off the task record, you have argv and argc, and that's how you access the values that were thrown. And then if you want to catch it, you say FS catch exception. And anyway, so that's how exceptions work.